Hello students, in my previous video we have discussed Faraday's laws of electrolysis, Faraday's first law of electrolysis and second law of electrolysis, and then some numericals based on both the laws. Now in this video we are going to do products of electrolysis. Sometimes what happens during the electrolysis, the products generated are different, though the reactants are same, but some conditions are different where the products formed are different. So here to discuss the same thing, I am taking an example where the electrolysis of NaCl, sodium chloride, in molten state and in the aqueous solution form. We will be comparing, we will be discussing that how the different products are formed when the conditions are a little different. For example, the first one, when NaCl in molten state, the electrolysis is carried out. The chloride ions, obviously NaCl in molten state will produce both the ions, Na positive and Cl negative. So Cl negative will undergo oxidation by losing electron, and when two chlorine atoms, they combine together to make chlorine gas. So this is oxidation happening, and oxidation always happens at anode. So at anode, chlorine gas will be evolved, which has come from chloride ions. Now at cathode, what will happen? Reduction. Reduction of what? Reduction of cation. Cation means towards cathode. Cation will start moving towards the cathode during the electrolysis. So they will take up electron and will produce sodium metal. So here the two products which are obtained on electrolysis of molten NaCl are chlorine gas and sodium metal. But same sodium chloride, when present in concentrated aqueous solution form, then the products are little different. What are the products formed then? The first case at anode, here also at anode we see that two chloride ions, they are combining to make chlorine gas. In presence of water, there are H positive ion also, OH negative ion also. But only chlorine gas is evolved. Oxygen cannot be evolved because of the overpotential of oxygen. And what is overpotential of oxygen? Overpotential means some potential difference between a half reaction, between its thermodynamically determined value and the potential at which this particular redox event is experimentally observed. So you can say this is the difference between the theoretical and the experimental value, which is called over voltage or over potential. This is directly related with the voltage efficiency. So in this case, out of two Cl negative and the oxygen, chlorine gas is evolved. Why? Because oxygen has over potential. So as compared to oxygen, chlorine gas is evolved. Now the second part at cathode. At cathode, what will happen? As I discussed, this is concentrated aqueous solution. It means water is producing its ions also. Water, it can produce OH negative ion, and water has tendency to produce H2 gas. At the second part, sodium ions, they can also take up electron and can produce sodium. But out of the two, if we compare their reduction potential, we can see the reduction potential minus 0.83 for this water and minus 2.71 for this cell. So out of the two, if we see at cathode, reduction has to take place, and the reduction potential of which one is more, so that they can which reaction will take place. So if we compare the reduction potential is high for water. So out of the two, the preferred option is for water. It means water will undergo reduction, and when water will undergo reduction, it will produce hydrogen gas and hydroxide ion. Now what will be left behind? Your sodium ion and the hydroxide which are produced, they can combine to produce your sodium hydroxide. So if we combine both the equation, this one is happening at anode, it means oxidation reaction, and this is happening at cathode, so this is your reduction. So both the reaction, when we combine them, we get the net equation. 2H2O from your cathode reaction, your reduction reaction, 2 Cl negative from your anode reaction, plus 2 Na positive ions because they are also present in the solution. And what are the products obtained? Hydrogen gas and chlorine gas, because these are the two reactions which we are combining, and at the same time these sodium ions are also present as reactant, and in the product side sodium ion are present in aqueous form. So the side product which is obtained along with hydrogen gas, chlorine gas, we are obtaining sodium hydroxide also. which was not here in case of molten state. Molten state we got only two products, chlorine and sodium metal. But because water was there, so water was also competing with sodium plus, and in that competition water has won the race. Why? Because the reduction potential is higher. Higher means less negative. So less negative value means it's higher. So H2O is producing hydrogen gas and the hydroxide ion, and this hydroxide ion they can combine with sodium to produce sodium hydroxide. So this is the net reaction for the electrolysis of NaCl in aqueous solution. So this is how the products of electrolysis may vary depending on the condition. It's not only the NaCl which will decide the product, it's actually the conditions also, whether it's in molten state or in your aqueous solution form. So this is one example of products of electrolysis. Similarly, 2-3 examples more given in your book. You can go through them. If you find any of them little difficult to understand, or any query related to other examples, or any query related to this example also, you can share with me so that I can take up those queries in my next video lesson. So thank you so much and enjoy studying. Bye bye.